So now we are discussing about logarithms. What is this logarithms? What you get under this topic? So like exponentials, what you have inside exponentials? You have exponential functions. What is exponential function? Functions you can plot. So you have a curve, you get a curve. So exponential function, if you just think about it, you can plot, you can draw. Similarly, log functions, you should be able to plot it. Functions are different to function, like people are different from country to country, right? So they have their own ways of doing the things. So in the log lesson, log has its own ways of doing his things. Exponentials have their own ways of doing things. Now, firstly, we will understand how this log function looks like, right? So now with your previous experience, log functions can be written as with many bases, log₂x. This is a function. Reason, x is your independent variable, y is your dependent variable, and you can plot it, and vertical line test satisfies. So it's a function. So this is a base. Base can be any number, right? Can be any number. So depending on that, the shape is changing. Okay, so we'll discuss that. Now, if you plot this log function, if you plot a log function, it looks like this. It's 1 here. So this is x versus y. This function is nothing but y is equal to log₂x. Y is equal to log₂x. So this tells you that this coordinate is 1, 0. Y coordinate is 0. Y coordinate is 0. So if you apply the x coordinate, which is 1, into that equation, what you get is y is equal to log₂ 1. You are substituting 1 into x. So if you look at the plot, you can see that y coordinate is 0. So that tells you that this should be 0, because that's indeed y coordinate. So underlying story would be log₂ 1 is 0 then. Underlying story would be log₂ 1 is 0. Okay. So similarly, if you observe or if you calculate, y is equal to log₁ 1 also 0. Y is equal to log⁴ 1 also 0. So that will tell you that all the log functions are going through 0. Now practically you have to understand, okay, they are going through 0. That can be like this, or that can be like this, right? Now you can see the shape is the same, but details are different. So this is log₂. This can be log something else. This can be log something else, right? So that we are going to discuss. But you can see all the log curves are going through this point, and they have similar shapes. So this is the basics. Okay. I'm going to take a point here. Suppose I'm going to take a point where x is equal to 2. So when x is equal to 2, you get this point on the curve. So that would be 2, log₂ 2. 2, log₂ 2. Right? 2, log₂ 2. So now this is the coordinate at that point. This is the coordinate at that point. So if you are a conscious student, you can see this. You got log₂ 2. Here I have written log₂x. Now as a conscious student, you are going to take those two. Then you try to see, observe, look at it carefully, taking a couple of minutes. You get log₂x here, and here you get log₂ 2. Now, if you look into these two, you have to understand what it is, right? Then, if you look at the picture and the curve and the point and what we have concluded, you will tell me that this guy, log₂x, is a curve. Is a curve. That is what you are going to tell me. Log₂x is this curve. Why? Because there is x. X can be any number. Yeah, it's a curve. Then what about this log₂? Then log₂, if you observe, log₂ is nothing but the y coordinate of this point. Y coordinate of this point is log₂, this guy. X coordinate is 2. So log₂ is y coordinate of this point, right? So this is a y coordinate of a point on the curve. We have to now precisely know this. Log₂, log₂x. Same thing you must understand in our previous lesson. 2 to the power x versus 2 to the power 2. In this case, log₂x versus log₂, right? So these two you have to understand and visualize logically. Okay. So now we will try to plot log functions with different bases. Okay. So the next one is log functions with different bases. Log functions with different bases. Okay. Now I'm going to draw one function and I'm going to say this one to be y is equal to log let's say 5x. Okay, log 5x. Then I need to draw log 10x and log 2x. So obviously you have few proposals, right? Log 2x or 5x, log 2x or 10x can be like this. The other one can be like this, right? It looks like this. Now which one is log 2x and which one is log 5x? And how do you logically understand that is what we are going to discuss. This will take some time. Maybe we will drag this to next week. However, this guy is going to be log 10x. And this guy is going to be log 2x. So log 10x is going under, log 2x is above. However, that you can see, so you can see log 2 to 10 going down, right? However, if you go below, you can see black to green is going up. I hope you understand what I'm saying. See? So this is the nature of the log function. So we see people, they play with these features. In the future, you need to find the area of functions, area under the curve, using calculus. So they will play with these small pieces. Okay. So the next part of log we will discuss next time.